Hey guys, welcome back to my channel. Today we're going to be solving move zero problem from LeetCode. Question is, given an array nums, write a function to move all zeros to the end of it while maintaining the relative order of the non-zero element. For example, you could have an array of 0, 1, 0, 3, 12. Output is 1, 3, 12, 0, 0. Note, you must do this in place without making a copy of an array. Minimize the total number of operations. So one of the hints that LeetCode gave us was in place means we should not be allocating any space for extra array, but we're allowed to modify the existing array. However, as a first step, try coming up with a solution that makes use of additional space. For this problem, as well as first apply the ideas discussed using additional array and the in-place solution will pop up eventually. I think this was like one of the best tips they could have given because I had a really hard time coming up with the solution, and this tip really helped me think through or come up with the solution using brute force. So let's try to do it what they suggested. And let's see, second array equals new int nums dot length. So this we've created a second array of a second array for of the same size as the one that is passed by. And so what that means is and another hint they also recommended is a two-pointer approach could be helpful. The idea would be to have one pointer for iterating an array and another pointer that just works on the non-zero element of an array. So let's do that. Let's do a pointer that does the non-zero element. Equals 0. And so for int I equals 0, I less than nums dot length. It was just basic stuff going through the array I plus plus. Alright, so what you want to do is if nums dot I doesn't equal 0, that means that it's a non-zero element. So you want to take that and add it to the copy it over to the second array. Second array dot I equals, nope, not second array dot I. You want to do secondary for non-zero element index because you want to just only copy over non-zero element equals nums dot I. And after that you want to do non-zero element, increment the non-zero element index. What is it? Up. All right. And then after the array is done, you want to copy it and this will give you the output. 1, 2, 12, 0, 0, 1, 2. Okay. I can't type. So it's 1, 3. So 1, 3, 12, 0, 0 is the answer. And then to do it in place is just replacing this with the one that's passed in. And instead of copying it over, there's one more thing you have to do, but let me show you what the problem is. So 1, 3, 12, 3, 12. We need to override these two with zeros. And the way we do that is while non-zero element is less than nums dot length, we need to non-zero element equals 0, non-zero element plus plus, and that gives you the final answer. And for me to prove that, I could, before we prove it, let me make sure, let me help you guys walk through this. So once we debug it, so the first element is a 0, so we're going to skip that. Second element is a 1, so that comes in here. And so 1 will get copied over to the first spot of the array. So it's a 1, 1. And we continue, and we increment non-zero element. So non-zero element is at index 1. And then at 2, it's 0. So we don't do anything. And non-zero element is still at index 1. And then at 3, the value is 3. And we copy 3 over to index of 1 in the array. So we have 1, 3 now. And then we're at 4. I is equal to 4. And so, which is 12. And that's non-zero. So we copy over whatever is in value 4 over to value 2. And that is 12. And after that, so we have an array of 1, 3, 12. But non-zero element index is still at index 3. And so at 3, we copy over 0 and continue copy over 0. And that's the end of the array. And so what happens down here is that we've looped through the entire array once, and then the last element that is non-zero is left, and then we just have to copy zeros into that. And that gets printed out as 1, 3, 12. And so this algorithm, this will run in big O of n time. And let me submit that to LeetCode. You're here. Your runtime beats 100% of Java submission. Wow. Okay. And then your memory usage beats 8.65% of Java submission. As there you have it. If you have any questions, leave a comment. If you can help me improve, leave a comment. Any critiques, fine. Thank you. Bye-bye.